Welcome to CXC Math TV. Today we're going to be going through the Pure Mathematics Unit 1 Paper 2 from June. This is the June 2022. And usually I would split this video up into the 3 different modules, but due to, not having as much time as all of us were going to school face to face now, fully, all teachers, all students, and so just going to be a long video going through the entire paper. So I hope that is fine. But with that being said, let us get started and we're going to have lots of fun. So question one right here. Let P and Q be two propositions. We need to complete the truth table. First, we have not Q. So when you negate true, you get false. Negate false, you get true. You negate true, you get false. And you negate false, you get true. So we've got 1 mark so far. Now it says not Q and P. So we're focusing on not Q and P. Now true and false is false. True and true is true. False and false is false. And false and true is false. Next thing we need is P or not Q and P. So we need down here, so now P or not Q and P. So looking at these two. Now true or false is true. True or true is true. False or false is false. And then false or false is false. Now it says hence state whether not Q and P or not Q are logically equivalent. State whether the statements are logically equivalent. So no, they are not. That give you 1 mark. Next mark is why. Why are they not equivalent? They're not equivalent since they are not equivalent since they yield different truth results. They yield or produced different truth results. And that's it. Get your 2 marks. Nice. Easy so far. Alright. Part B says determine the values of A, B, and C such that 2x squared minus 7x plus 12 is equal to A in bracket x minus 2 times x minus 1 minus B in bracket x minus 3 plus C. So first let's expand the right side. This becomes A times x is x squared. Then the signs are the same, so we just add the 2 and the 3, so it becomes minus 3x. Then minus 2 times 1, that becomes plus 2. Then over here it is minus bx plus 3b, and then we have plus c. Expanding the a, so we have ax squared minus 3ax plus 2a minus bx plus 3b plus c. Remember, this is equal to 2x squared minus 7x plus 12. Now, in this case, in order for the equation to be true, then we know that we can equate coefficients. Let's write that. So, equating coefficients So let's start by equating x squared coefficients. So if we equate coefficients going with the x squared terms, what we're saying then is, I'm underlining the x squared terms on the left and the right. So these are our x squared terms, right? So only one x squared term, so in that case, 2x squared must be equal to ax squared. So that means that if we divide both sides by x squared, then the a must equal to 2. So a is 2. So find A already, very easy. Next thing now is we need to equate the coefficients of our x. I'll underline them in black. These have the x in it, right? So equating coefficients of our x, right, we end up have minus 7x And minus 7x is equal to minus 3ax minus bx. We can divide through by x. If we divide through by x, then this becomes minus 7 is equal to negative 3a minus b. But remember what was a? A was 2. So minus 7 is equal to minus 3 times 2 minus b. Bring the b to this side, so it becomes positive b equal minus 3 times 2 is minus 6. Bring the negative 7 to the other side, so it becomes plus 7. 7 minus 6 equal 1. So we get b equal 1. Good. Now finally, we need to equate our constants. So let's go ahead and equate our constants. Equating the constant, it becomes, so equating our constants, CON mean constants. The constants, it's 12 is equal to, our constants is just 2a plus 3b plus c. So this is now 2a plus 3b plus c. So 12 equal 2 times a, which is 2, plus 3 times 1 plus c. Now 2 times 2 is 4, 4 plus 3 is 7, so 7 plus c equal 12. So therefore c equal 5. So that's our answer. Finish. Alright, so just to write it out finally we're going to 9 marks for this. That's really nice. So therefore we can tell them a equal 2, b equal 1, and c equal to 5. Now always remember, in an exam you can always check back your answer. How you check back your answer? Put a, b, and c as that value. So write it out. So put a as 2 times your x squared minus 3x plus 2. Then put back your b as, b is what, 1, so it become minus in bracket x minus 3, and put your c as your 5. Expand it and see if you get that answer. This is 2x squared minus 6x plus 4 minus x plus 3 plus 5. Keep on going. This become 2x squared, then minus 6x minus x is minus 7x. Then 4 and 5 is 9 plus 3 is 12. We get back the same thing when we expand it, so we realize that yes, these are our answer. Right? So we verified it and we're good to go. Nice. Part C. Part C says to solve the inequality, the modulus of 3x plus 2 greater than or equal to 4. First thing is you have to remember this rule when doing modulus equation. The modulus of A is greater than or equal to B, then it means that A is less than minus B, or A is greater than B. That's the rule. So in that case, our a is 3x plus 2. So in that case, we get 3x plus 2 is greater than negative 4, or 3x plus 2 is, 3x plus 2 is less than or equal to negative 4. I just wrote down the rule and I'm writing the incorrect thing right here. Sorry about that. 3x plus 2 is less than or equal to negative 4, or 3x plus 2 is greater than or equal to positive 4. From that, we bring over the 2. So saying 3x is less than or equal to negative 6. So x is less than or equal to negative 2. Or from this side, we're saying 3x is greater than or equal to, bring over the 2, that becomes 2 here. And divide now through by 3, x is greater than or equal to 2 over 3. Now always test it. Always do what? Test it. So put in a number less than negative 2 to see if any portion is not valid. So 3 times, maybe let's go with negative 3 plus 2. That is negative 7. When you take its modulus, that would be bigger than 4. So notice, yes, that is true. Put in a number bigger than 2 over 3. So let's use 1. 3 times 1 plus 2, 5. That's of course bigger than 4. So notice both sides is true. So this is our answer. Easy 5 marks. I don't know why this is 5. Easy 5 marks. There's nothing to it. Alternately, some persons might learn it this way. So I'll just put it on the paper. This is method 1. Some persons may have been used to it this way. Method 2, where your teacher may teach you to square both sides. Square both sides. So I'm just writing it for those who would have learned it this way. So it end up get 3x plus 2 all square is greater than or equal to 16. Expand it out. This becomes first term square minus twice the product of, well, plus twice the product of the two. 2 times 3 is 6. Double of that, that's 12x. Plus 4 is greater than or equal to 16. Bring it over to 16, it becomes 9x squared plus 12x. That becomes 4 minus 16. 4 minus 16 is negative 12, greater than or equal to 0. From that, all of them have 3 in common, so we can divide through by 3 to get 3x squared plus 4x minus 4 greater than or equal to 0. From that, we factorize greater than or equal to 0, and to factorize it to get 3x squared must be 3x x. Signs are different, the bigger number get the positive, so we know it's 2 and 2, but where gets the signs are different, the bigger number get the positive, so that would be the plus 2 here and the minus there. From that, we realize we have our quadratic inequality where the roots are negative 2 and 2 over 3. And we need greater than 0, so we need these pieces. We need the branches. If we need the branches, then clearly our answer would be x is less than or equal to minus 2, or x is greater than or equal to 2 over 3. So I showed you both methods because some persons might be used to squaring both sides. That's not my preferred choice. I prefer you know the law. So I did it both ways for persons who are practicing and they're like, my teacher didn't teach me that. That's fine. You can either use the rule or you can square both sides and work it out. Hey! Part D needs us to solve this log equation for 6 marks. Easy piece of 6 marks. So we have log base 5 of x plus 2 plus log base 5 of x plus 6. That's equal to 1. In that case now, we get log base 5 of x plus 2 times x plus 6, because we have to remember the rule with logarithm that when the bases are the same, log a plus log b is the log of a times b. You have to remember that rule. So in that case, this now becomes, remember the definition of logarithm, the log, and even if you didn't want to remember that, right? Let's say this 1 right here. I'm bringing out the calculator. Some persons probably know log 5 of 5 is 1, right? So now you can replace this 1 right here with 1 as log base 5 of 5. In that case now, if you have log a on one side, log a, and it's equal to log b, then that means a equal b. So in that case, we can say, so x plus 2 times x plus 6 is equal to 5. So expanding, we're getting x squared plus 8x plus 12 is equal to 5. Bring over the 5 so it becomes x squared plus 8x. 12 minus 5, that becomes 7 is equal to 0. Then we can factorize it. X, x, signs are the same, both are positive. So 7, 1, plus and plus. So in that case, x is equal to minus 1, or x is equal to minus 7. Now with logarithms, you cannot just stop right there. You have to test it to see if it actually works. So look, we're going to put in our calculator log base 5 of minus 1 plus 2 plus log base 5 of minus 1 plus 6. And we should be getting 1. Let's see if we get 1. Yes, we do. So we know this one works. No, negative 7 cannot work. Why does negative 7 does not work? Because the log of a negative number does not exist. Alright, so this one right here, you can write madness. Write it on the paper. Madness. This one will not work. So you're telling them only the negative one will work because you cannot evaluate the log of a negative number. So just to verify, if you change a negative 1 to negative 7, your calculator going to say math error. Cannot do it. See it there? That one don't work. Nice. Alright, that was part D. All right, now number 2. So we finished question 1 already, easy. It says f of x is equal to 3x plus 1 over x. And g of x is given. Show that f inverse is this. So first thing, we need to find f inverse. So let's start by writing down our f of x. So our f of x is 3x plus 1 over x. So to find the inverse, the first thing we remember is replace f of x with x and x with y. So 3y plus 1 over y. And make back y the subject. So cross multiply, so x times y equals 3y plus 1. Bring over the 3y, so we get xy minus 3y is equal to 1. In that case, we can factor out the y, and we have x minus 3 is equal to 1. Then we divide both sides by x minus 3. And so this cancel this. So now we end up get, or y is 1 over x minus 3. So therefore, our f inverse of x is 1 over x minus 3. That's our answer. Very, very, very easy. Nice. So easy so far. Hence or otherwise, we need to determine an expression for f inverse of g of x. That's all they're asking us to do. Put g of x into the inverse function of f. So in that case, let's look back at what is g of x. I'm just zooming out so I can see my g of x. So in that case now, f inverse of g of x is equal to 1 over, because remember this is f inverse, 1 over g of x, because remember where x is in f inverse, replace it with g of x. Right, so it is 1 over, where x is, we put g of x minus 3. So this is it. Right, this is f inverse of g of x. In that case, it becomes 1 over g of x, remember, is e to the minus 2x plus 1, and then we subtract 3. So in that case, it simplifies to be 1 over e to the minus 2x, 1 minus 3. 1 minus 3 is minus 2. And that is our answer for f inverse of g of x. That was very easy. Surprisingly easy, but no problem. They give away easy questions sometimes. So that is it for part 2. Okay. Part 3, they're asking, well, part B. Part B. Part B, they're asking us to solve this equation here. Now, here's the thing. I see 2 to the 2x and 4 to the 2x. The first thing jump out to me is that 4 to the 2x can be rewritten as 2 squared to the 2x, which can also be rewritten as 2 to the 2x all squared. So that's the first thing I would do. First thing is I'm going to rewrite it as 6 minus 7 over 2 to the 2x minus 3 over 2 to the 2x all squared equal to 0. Now when I reach here, so I'm like, well, 2 to the 2x is going to give me some trouble, so I'm going to call it m. Let m equal 2 to the 2x. So now the equation will look a little better because it's 6 minus 7 over 2 to the 2x is m minus 3 over 2 to the 2x square is m square equal to 0. I'm going to multiply the equation through by m square. So it becomes 6m square minus m squared times 7 over m is just m, so minus 7m. Then I have minus 3 is equal to 0. Alright? Now, right here now, we reach the point where we should factorize. Right? So, we need to factorize it, but first thing I like to do is check if I can factorize it. Don't worry guys, I'm just looking at the discriminant. The discriminant tells me if I can factorize it. Alright, so b squared minus 4 times a times c. I like to just put that in the calculator first. 121 and square root of 121 is 11. So since I'm getting an integer value, yes, it can be factorized. Alright, it can be factorized. So since I know that it can be factorized, I'm just going to set it up now. Alright, so I factorize, put my two brackets. This is saying signs are different. The bigger number get the negative. The bigger number gets the negative. So to get 6m squared, I'm just thinking it's 6m and m. Alright, now which two numbers I multiply to get negative 3 has to be 3 and 1. Let me see if that would make sense. This is 18, 1. Okay, that's not gonna work. Alright, that's not gonna work. Because at the end of the day, we need it to balance right here. So, alright, I'm trying to factorize it in one step, guys. But since it's taking me so long, I'm just gonna solve it using quadratic because I'm taking too long. So guys, it's in the evening I'm recording this video. A little bit fatigued after a long day of school, so the factorizing not as smooth today. So I'm just gonna use the quadratic formula. M is minus b, so 7 plus or minus the square root of b squared minus 4 times a times c divided by 2a. I know it's disappointing that I'm using quadratic formula, but yes, it's been a long day, so usually I'd factorize it straight off the bat, but that's fine. So 7 plus square root minus 7 square minus 4 times 6 times negative 3, close the bracket, divided by 2 times a is 12. Put that in the calculator and we get m equal 3 over 2, or m equal, put the next one in the calculator when the sign would be minus, we get m equal negative 1 over 3. Oh, I see how it, okay, I see where I was factorizing wrong now. So that's it. Those are your two m values. But remember, when you solve for m, you're not finished. Remember, m was what? m was 2 to the 2x. So in that case now, right, we're saying 2 to the 2x equals 3 over 2, or 2 to the 2x equal negative 1 over 3. But can you raise something to a power and get a negative answer? No, so this one is what? Crazy madness. You cannot raise a number to a power and get a negative result. So only need to look on this side. 2 to the 2x equal 3 over 2. And we need to solve for x. The first thing we can do now is log both sides. So 2 to the 2x log 2 is equal to the log of 3 over 2, or 1.5. Then we can do what? Divide both sides by 2 log 2. So divide both sides by 2 log 2. So the log 2's cancel and the 2's cancel. Then we'll put this in our calculator for x. So log 1.5, and then we divide it by 2 log 2, and that is equal to 0.292. X equal 0.292, and this is giving their answers to 3 significant figures. That's 3 significant figures. Alright, because in pure math, oftentimes you're supposed to give your answer to 3 sig fig. Look at the front of the page, right? It usually tell you somewhere here, unless otherwise stated in the question, you get marks for this, guys. Always give your answer to what? 3 sig fig. Always read the rules, guys, please. So in that case, we write our answer to 3 sig fig, 0.292. Now, let's verify if this is true. So checking it, this is our answer, right? So we need to put this in our calculator and get 0. So 6 minus fraction button, 7 over 2 raised to 2 times our answer, which is the 0.29, minus fraction button, 3 over 4 raised to 2 times our answer. This should be giving us 0, so drum rolls for me. Yes, we get our 0. So you see that the answer is correct. Alright, so verified. You do a question like this and you write soft. You write soft with a capital T, because that was entertaining nonetheless. Okay, part C. Part C, it says the function f of x equal 2x cubed minus px squared plus qx minus 10 is divisible by x minus 1, and it has a factor of -6 when divided by x plus 1. Find the values of p and q. So the first thing that, my apologies, the first thing that we can do, since it's divisible by x minus 1, then that is saying that x equal 1 is a root. And if x equal 1 is a root, that means f of 1 is equal to 0. And so that implies, when we put in the 1 here, that's 2 times 1 cubed minus p times 1 squared plus q times 1 minus 10, that's equal to 0. We get 2 minus p plus q minus 10 equals 0. So in that case, we can bring the 10 and the 2 to the other side. So that's minus p plus q equal 2 minus 10 is -8. Bring it over here, it's +8. Then they told us when it's divided by x plus 1, it leaves a remainder of -6. So they're telling us f of -1 there is equal to -6. So that means 2 times -1 cubed minus p times -1 squared plus q times -1 minus 10 equal -6. This becomes -2. This becomes minus p. This becomes minus q. Minus 10 equal -6. From that, we simplify it to get our two equations. Minus p minus q equal. Bring it over and bring it over. -2 minus 10 is -12. -12 when it comes to the other side is +12. 12 minus 6 is 6. So now we have our two equations and our two unknowns. This is equation 1 and this is our equation 2. Now I like to add them and eliminate or subtract them, but I just like elimination method. So I will add them. So adding, I notice what happened is minus p plus minus p become minus 2p. Then q plus -q gone. Then 8 plus 6 is 14, which implies p equal, divide out -2, p is -7. Once I get p is -7, I need to find q. So negative of -7 plus q equal 8 using equation 1. And negative and a negative become positive. So 7 plus q equal 8. So therefore q is just 1. How many marks for that? That's so easy. That should be 4 marks. But they gave us 6. That is amazing. So in that case, we can write down p equal -7 and q equal 1. No problem. Bet they're going to ask to factorize it next. Oh, I'm ashamed because they did not ask to factorize it. I thought they were going to ask to factorize it next, but they didn't. Next part, they tell us the roots of the cubic equation is these. Given that alpha beta plus alpha gamma plus beta gamma is 3/2, and they gave us this equation, determine the equation with roots this. First thing is, from the original equation, you have to remember this. A quadratic equation, right, or a cubic equation rather, you have to remember that alpha plus beta plus gamma, the sum of the three roots is equal to minus b over a. You have to remember that formula. So the sum of the roots is, a in this case is 2, b is -1, c is 3, and d is -1. So minus b, it becomes minus -1 over 2, which is 1/2. So that's the sum of the roots. Next thing is the pairwise product. So alpha beta plus, why does it keep disappearing? Beta gamma, come on, stop doing that, plus alpha gamma. This is equal to c over a. So that's 3/2. Then finally, alpha times beta times gamma. Alpha times beta times gamma is minus d over a. Guys, I really don't know why it keeps disappearing the writing, but maybe it's the color. Let me change it. And in that case, this becomes d, which is minus d minus minus 1 is 1 over 2. So good now. Now we need to say find the equation whose roots are 1 over alpha, 1 over beta, and 1 over gamma. So the new sum, I like to call it new sum. The new sum is 1 over alpha plus 1 over beta plus 1 over gamma. Using LCM, the LCM is going to be alpha times beta times gamma. Alpha into this leaves beta gamma. Beta into this leaves alpha gamma. And gamma into this leaves alpha beta. Now we just worked out that all of this, we worked out it was 3 over 2. So it's 3 over 2 divided by alpha beta gamma, which we worked out was alpha beta gamma was a half. Then you put that in a calculator. I know many persons are saying that's crazy, that's just 3. But for those who are not so confident, you can actually put it in a calculator. 3 over 2 divided by half. If you're not sure, put it in a calculator. I know many of us are quick with the math, and we know that was 3. No problem. That's fine. Some persons won't be as quick. Nothing is wrong if you put it in the calculator to verify. So that's the new sum. The next you need is the new P2. The new P2 is a pairwise product. When we multiply 1 over alpha times 1 over beta plus 1 over the next two root product of the next two roots, 1 over alpha times 1 over gamma plus we'll multiply 1 over beta times 1 over gamma. All of this is just, this is now, we need to find the LCM, right? And the LCM, let me draw the line. The LCM would be what? Alpha, beta, gamma. Don't? LCM is alpha, beta, gamma. Now, alpha, beta into this leave gamma. So gamma times 1 is gamma. Alpha, gamma into this leave beta. And beta, gamma into this leave alpha. But alpha plus beta plus gamma is what? A half. This is a half divided by alpha times beta times gamma is what? A half. So P2 works out to be equal to P2 works out to be equal to 1. But guys, that's so crazy. Look, they even told, we didn't need to write down C over A. They even gave us it in the question. I don't know why they would give us that in the question. That makes it boring. Okay, finally now we need P3, right? Now P3, guys, is a product of the three roots. So it's 1 over alpha times 1 over beta times 1 over gamma. In that case, it's 1 over alpha times beta times gamma, which is 1 over alpha times beta times gamma is a half. 1 divided by half, I know many of us is saying the answer already, but still, put it in the calculator if you're not confident. 2, right? So remember that this is 1, this is 3, this is 2. So the next thing to remember now is the form of the cubic equation. So the new cubic equation, always remember it's x cubed minus the sum of the roots times x squared plus p2 times x minus p3 equals 0. So it's going to be x cubed minus the sum of the three roots now, 3x squared, plus p2, and p2 is 1, so 1x minus p3 minus 2 equal to 0. That's your answer. Easy. Soft. Full 6 marks. Nice. And guess what? We finished 2 questions already. This was so boring. Question 3. Question 3 is in module 2, and this is trigonometry, right? So right here now, we always do proof starting from the left-hand side. So the left-hand side start with giving us tan theta, sine theta over 1 minus cos theta. But then tan theta is what? Sine theta over cos theta, and that's being multiplied by sine theta over 1 minus cos theta. But then sine times sine is what? Sine squared theta over cos theta divided by 1 minus cos theta. We can go further and rewrite this right here as sine square theta over cos theta and dividing by 1 minus cos theta, right? But dividing is the same as change the division sign to multiplication. There's a reason why I'm doing this. I want us to see all the steps clearly. When you change it from division, it becomes multiplication. Then we reciprocate what's after the division sign. And it was 1 minus the cos theta. So that's it. Now, we're almost finished, guys. We're almost finished. We have to remember now that sine square is 1 minus cos square. So this becomes sine square is 1 minus cos square theta over cos theta multiplied by 1 over 1 minus cos theta. Guys, again, we're what? Almost finished. Now we're going to do what? Break up 1 minus cos square as a difference of 2 square. Recall a square minus b square is a minus b times a plus b. So this right here become 1 minus cos theta times 1 plus cos theta over cos theta multiplied by 1 over 1 minus cos theta. Then guess what? Guess what? Guess what? 1 minus cos theta going to cancel. This going to cancel the 1 minus cos theta here. So now we're left back with 1 plus cos theta times 1 over cos theta. So 1 plus cos theta over cos theta, which is, you can separate it now as two fractions, 1 over cos theta plus cos theta over cos theta, and cos theta over cos theta is 1. So in that case, we get our cos theta over cos theta, which we know is 1. So this part becomes 1 over cos theta plus 1, and that's your right hand side. I know, guys, I missed out the final step. You're supposed to write it back in this form to tell them it is 1 plus 1 over cos theta, but you do the right thing, right? Put the next step right there. But that was fun. That was very fun. Nice. The next part says to solve this equation. Now quickly I realize that it has tan, so I am going to use a u substitution. So I'm going to say let m equal tan theta. So I notice this is really m squared minus 2m equal 3. So this is m squared minus 2m minus 3 equals 0. I can quickly factorize it. This is m, 3 and 1. Signs are different. The bigger number get the negative, so minus and plus. This is saying m equal negative 1 or m equal 3. But remember what was m? M was tan theta. So tan theta is negative 1 or tan theta equal 3. From this I draw my circle and I know that I want where tan is negative. First thing, remember this. All schools teach crap. So first thing is that tan is positive in the first and the second quadrant, but we need minus of it. So we're focusing on these two quadrants today. First take tan inverse of 1, and tan inverse of 1 we know is pi over 4 in radians. If you don't remember, put a calculator in radians and do it. Tan inverse pi over 4. Tan inverse 1 I mean. And you're going to get a pi over 4. Right? So we all knew that. And if we didn't, that's okay. We have our calculators anyway. So in that case now, we need what? We need in the second and the fourth quadrant. In the second quadrant, it's pi minus your first quadrant answer. And in the fourth quadrant, it is 2 pi minus your first quadrant answer. So those will give you the solutions. So in that case, let's write down the solutions from this side of it. So in that case, we're getting theta equal pi minus pi by 4 is 3 pi by 4, or theta equal from this side, we're getting 7 pi over 4. That's two answers we're getting. Now, over here now, where the tan theta is 3, we draw our circle. We need where tan is positive, so we're looking at the first and the third quadrant. So first, theta gonna equal tan inverse of 3, or it is equal to what? This quadrant down here is pi plus tan inverse of 3. Now tan inverse of 3 I know won't give me an exact value. I would leave it as it is. Tan inverse of 3, that don't look pretty. But just in case you wanted to write 1.25, and then pi plus that is add pi to it. Just in case you wanted to give them the numeric value, or 4.39 in radians. So all our final answers, I'm just going to write all the final answers right here now. So in that case, theta is equal to 1.25 radians, or it is 3 pi over 4, or it is 4.39 radians, or it is 7 pi over 4. These are our answers. Let's check it out. Check it out. Check it and see if it works. Check it. So this is how we check it. We're going to put in tan. What's our answer? Radians is the 1.25. Close the bracket, and we're supposed to square it. Minus 2 times the tan of our 1.25. And what are we supposed to get? Drum rolls. We're supposed to get 3. Input it in the calculator. We do get our 3, showing you that we're correct. The only reason why it's not exactly 3 is because we used a rounded off value. Remember, it was 1.249 something something something. So if you use the exact value, you'd have gotten the right thing. Alright, this one says show that 4 cos theta equal this. It says show. So how I interpret this, many times, we know that it can be expressed in the R sign form, right? Now, typically what I'd want us to do, right? Typically, but because they say show, this is a different terminology. Typically what I always say is this: if you rewrite it, it is really 3 sine theta plus 4 cos theta, and it's equal to 5 sine in bracket theta plus 0.927 radians. C mean radians, alright? Typically what I'd say is, first thing you find R. Always remember it can be expressed in the form R sine in bracket theta plus alpha, where R is equal to the square root of R is equal to the square root of a squared plus b squared, and alpha is equal to tan inverse of b over a, right? And b in that case is 4 and a is 3. Now because it says show, then automatically finding r and alpha does not suffice. It would not be a show. So to do a proof, you have to start by expanding your left hand side, and it need to work out. All right, so let's go ahead and show them the full proof. So first thing is, we're going to tell them, so this is how we're doing it now. It's actually a proof now. So we're going to tell them now, right, that look what we're telling them, guys, follow. We're telling them that r sine in bracket theta plus, it's actually from the right side, but it's not really. It's fine. The R 5 sine in bracket theta plus 0.927 radians, that is equal to expand using compound angle. All right. So using compound angle, this is 5 times. Remember, sine A plus B, you have to remember, is equal to sine A cos B plus cos A sine B. So in that case, it's equal to 5 sine theta sine 0.927. I said sine, I'm so sorry. Cos. Plus, I'm going to put a bracket here. So it is sine A cos B plus cos A sine B. And sine B, sine of 0.927, close the bracket. So that's equal to, expanding the 5, it becomes 5 sine theta cos 0.927 plus this part becomes 5 cos theta sine 0.927, and in that case now it's equal to, now you put this part in your calculator, put that part in your calculator now, 5 cos 0.927, that is, there you go, you get your 3, so this is now 3 times the sine of theta. But since, remember, you want to get your full 5 marks, right? So I would show all the steps. Show them that you're telling them that multiplication is commutative and associative. So it's 5 cos 0.927 times now sine theta plus 5 sine 0.927 cos theta. Then we're telling them that this piece will work it out in our calculator, and this piece gave us our 3 sine theta, and then this piece, when you put it in a calculator, when you put in 5 sine of that, you get your 4. So tell him that is plus 4 cos theta, and you can flip it around now and say this is indeed 4 cos theta plus 3 sine theta. So now we can tell them our conclusion, and we can tell them, therefore, 4 cos theta plus 3 sine theta is equal to our 5 sine in bracket theta plus 0.927. That's it. Part 2, it says, hence or otherwise solve the equation equal to 0. I would go with the hence. We just realized that, remember, 4 cos theta plus 3 sine theta, we just worked it out that this left side is now 5 sine in bracket theta plus 0.927 radians, and that's equal to 0. So going with the hence is way easier instead of otherwise. You can solve it otherwise, but I'm going with the hence. So going with the hence now, we divide through by 5. That becomes sine of theta plus 0.927 equal to 0. So now we draw our circle, right? Draw our circle, and then where are we? Sine is positive. Well, 0 is not really positive or negative, so we're just in the first two quadrants. So in that case, the first quadrant answer would be sine inverse of 0. Well, actually, it's not theta by itself. The first quadrant answer, you take sine inverse of 0, which you'll get 0. So in that case, we're telling them that therefore this part right here, this represents your sine x, right? So sine x equals 0, so x is sine inverse 0. So therefore we're telling them our x, or theta plus 0.927 is equal to 0, or theta is equal to pi minus, or theta plus 0.927 is equal to pi minus the first quadrant answer of 0. So in that case now, we can go ahead and solve for theta in both cases. So from case 1, we get theta equal negative 0.927, or theta equal, bring over this, we get pi minus 0.927. That's our answer. But remember, they didn't give you a specific region. Did they tell us theta is between 0 or 2 pi? No. So in that case, I would give them the general solution. So I'm just giving them the general solution. So the general solution in this case now, set up a general solution. In that case, it is minus 0.927 plus 2n pi, where n is of course, integer values, right? And also our next answer is pi minus 0.927 plus 2n pi. All right, that's our general solution. That's method 1. Now I'm just going to move away from the exam paper and do it method 2 on a blank screen. So method 2, for those who like to show off, 4 cos theta plus 3 sine theta equal to 0. This is method 2. Method 2, you divide through by cos theta. Dividing through by cos theta, you get, let's not divide through cos, because you can, but that's going to be a little bit more challenging. Let's divide through by sine theta. No, divide through by cos. Guys, it doesn't matter, I'm just looking for the easier one. I'm trying to generate the identity time. So divide through by cos, it becomes, want you to see it, dividing through by cos, dividing through by cos, dividing through by cos. Cos over cos gone, so that's 4 plus sine over cos is tan, so this is 3 tan theta equal to 0. Bring over the 4, so 3 tan theta equal to negative 4, and so tan theta is equal to negative 4 over 3. You draw your circle, you want tan to be negative. Tan is negative in, remember, all schools teach graph, so tan is negative here and here. So taking tan inverse of negative 4 over 3, that would give you tan inverse of 4 over 3, I should say. Taking tan inverse 4 over 3 would give you the 0.927, right? But we need the second quadrant answer, which is right here, so it would be pi minus 0.927. Or another answer going to be 2 pi minus 0.927. That is it. Notice you get the same answers whether you use this method, method 2, or whether you use the hence method. So I did the hence and I did also the otherwise. This method 2 here is otherwise. For those who like, to be a little unique and go otherwise, that's fine. Part D. Given that sine A is 1 over 3 and A is obtuse, anytime it's obtuse, you can just picture a triangle in the second quadrant, right? So in that case, A is obtuse, right? So this is the triangle we're focusing on, right? And they're telling us, of course, that the opposite is 1 and the hypotenuse is 3. Calculate the value of cos A without using a calculator. So the first thing is we need adjacent. Let's call adjacent x. So first thing we do know is that opposite square plus adjacent square equal hypotenuse square. So x square equal 3 square minus 1 square, x square equal 8, x equals square root of 8. So in that case, the cos of theta is just going to be the square root of 8, remember cos theta is what? Adjacent over the hypotenuse. So it's square root 8 over 3. Remember they said no calculator? So that is it, square root 8 over 3. We could break it down and tell them that square root 8 is square root of 4 times square root of 2 over 3. And square root of 4 is 2, so this is 2 root 2 over 3. If you wanted to tell them this is the answer, that's also fine. Doesn't matter. Right? So that's one way of doing it. And right, just in case you don't believe it, look, I'm going to show you that this is cos theta. If you were to take out your calculator and do this, let me put the calculator back in degrees. Sine inverse 1 over 3. This will give you what? Theta, don't? Give you theta. Once you get theta, look at this. Cos of theta is 0.942. Now put this in a calculator. 2 root 2 over 3. Guaranteed to get the 0.942. See there? Same answer. That's because they are the same. Alright? So we verified that this is our answer. Easy 4 marks. Question number 4. Question number 4, it says a circle has equation x squared plus y squared minus 10x plus 4y minus 5 equal to 0. And they want us to determine the center and the radius of the circle. First thing, we have to complete the square among the x and the y terms. So group the x and group the y. So this is x squared minus 10x plus y squared plus 4y minus 5 equal to 0. Complete the square among the x terms. So drop the square. Half the coefficient of 10 is 5. Put a square, then subtract 5 squared. Plus, drop the square. Half the coefficient of 4, that's 2 squared, and you subtract 2 squared. Minus 5 equals 0. Bring all the numbers to the other side. This is x minus 5 squared plus y plus 2 squared equal to positive 5 plus 5 squared plus 2 squared. 5 squared is 25. 25 and 5 is 30. 30 and 4 is 34. So x minus 5 squared plus y plus 2 squared equal 34. So the center is 5, negative 2, and the radius, always remember the equation when it's in this form is equal to r squared. This is r squared. So our radius is the square root of 34. That's your answer. Nice. So you can actually picture your circle if you'd like. I don't like to picture it here. I like to picture it down here. So down here when they say determine the equation of the tangent at 2, 3, I like to draw my circle. Alright, and the center is 2, 3. And then now, oh, sorry. The center is 5, negative 2, guys. Sorry. The center is 5, negative 2. And the point of tangency is 2, 3. So 2, 3 is somewhere here. And this is the tangent we want. We want to find the equation of this line. Now, first thing, to find the equation of the tangent, we need gradient of the tangent. But to find gradient of the tangent, we first have to find gradient of the normal. And then the tangent is perpendicular to the normal. So the gradient of the normal is equal to y2 minus y1 over x2 minus x1. So 3 minus negative 2 over 2 minus 5, that is positive 5 over 2 minus 5 is negative 3. So the gradient of the normal is minus 5 over 3. Now the gradient of the tangent is negative 1 over the gradient of the normal. So it's a negative reciprocal, so it becomes 3 over 5. Now that we get the gradient of the tangent, we can write down the equation of the tangent. The equation of the tangent is now y minus the y value at the point of tangency, y minus yp equal gradient of the tangent in bracket x minus xp. So this is y minus 3 equal 3 over 5 in bracket x minus 2. This is the equation of the tangent. Now, they didn't say to simplify it. They didn't say put it in the form y equal mx plus c. So if you stop right here, this is also correct. You get your full 4 marks. They didn't say put it in the form y equal mx plus c. So we finish. Next part, it says determine the equation of the plane that passes through this point, which is perpendicular to the vector given right here. So first thing is if you have the plane, right, and it's perpendicular to this vector, we have our vector v given, then vector v acts as a normal to the plane. And the equation of a plane is r dot n is equal to any known point in the plane dot the normal. And the normal in this case is our v. So it becomes r, remember, represents a general point, x, y, z, r dot your normal. And guys, I do not know why the letter keeps disappearing. It is really not my fault. I'm trying my best. So r dot n, r is a general point, x, y, z. N, which is the normal, is 3, 2, 4. So the dots keep disappearing. My gosh. R dot n equal to the known point 0, 2 minus 2 dot the normal. This is 3, 2, 4. Working it out, the dot product now. So multiply x terms. X times 3 is 3x plus y times 2 is 2y plus 4 times z is 4z equal to 0 times 3 plus 2 times 2 plus 4 times negative 2. So the equation of the plane is 3x plus 2y plus 4z. This is equal to 0 plus 4 minus 8, and 4 minus 8 is negative 4. That's your answer. Easy. So, now part 2. Part 2 says determine the angle between the vector 3i minus 2j and the x-axis. Now for me, guys, I cannot see things if I don't sketch it. So I'm just sketching it. I'm just focusing on the xy plane because they didn't give me a z value. So 3i minus 2j would be the vector 3 minus 2, right? And that is 3 on the x and minus 2 on the y. This is the vector, and we want the angle between this vector and the x-axis, right? So the angle between this vector and the x-axis. So this is the angle that we want. That's the angle, all right? So that's the angle. Now, right here, so now many persons, we can go ahead and find this angle, right? Easily, because the x-axis is which? The x-axis, all right? The x-axis right here, and this angle, we can use tan inverse to find that, because look, the length of this line is what? 3. The length here is what? 2, right? The length is 2. So in that case now, theta is just tan inverse. Theta is what? How do you find this? When you have the opposite and the adjacent, we use tan. So theta is tan inverse what? Theta is tan inverse your opposite over your adjacent. But remember that because we're below the x-axis, it's negative. And you put that in a calculator. Right? So you can just put in tan inverse 2 over 3 and then negate it. So the angle is just negative 33.7 degrees. That's the angle between the x-axis and this vector. Very easy. Alright, the next part, it says the parametric equation of a line is given by x is 2 plus 5 lambda, y is minus 3 plus 4 lambda, and z is 4 minus 2 lambda. Determine the coordinates of the point where the line crosses the xy plane. Where the line crosses the xy plane, so on xy plane, the z value is equal to 0. So in that case, 4 minus 2 lambda equals 0. So 2 lambda equals 4. So lambda equals 2. Since we get lambda is 2, we can use that to find out our points. So x, remember, is 2 plus 5 lambda. And lambda is 2, so it's 2 plus 5 times 2. 5 times 2 is 10. 10 plus 2 is 12. Y is minus 3 plus 4 times lambda, and lambda is 2. So this is now 8 minus 3, which is 5. And z, the z value is 0, right? So in that case, the point is 12, 5, 0, or not. And that's it. Nice. Now, it says a point P moves in the xy plane such that, guys, anytime I'm doing questions, I like to sketch it. Guys, just sketch it. I cannot just do it. Maybe you're brilliant enough to do that. I have to sketch it. A point P moves in the xy plane such that it is the same distance from the point A. So I just have to sketch it because that is how I am. So we have some point P such that it is the same distance from the point A. A is the point 1, 2. So this is my point A, as it is from the line x equals 3. The line x equal 3 is a vertical line. The line x equal 3 is a vertical line. So the line x equal 3, let's say this is the line x equal 3. And we have p is moving so that it is equidistant from the point A and the line x equal 3. So wherever p is, I'm just putting p as an arbitrary point. Guys, p is just an arbitrary point. So since p is an arbitrary point, right, then what they're telling us is if I make dotted lines, right, the point p is what? Remember, it is the same distance from the point A as it is from the line x equal 3. Maybe P wouldn't be here then. We want to show some sort of equidistant, but wherever we put P, let's say P is right here. It's just, let's say P is right there. What we do know is that it is equidistant from the line x equal 3. Now this wouldn't show equidistant. It's so hard to show equidistant accurately. So let me put P maybe. I don't want to use too much space. So let me go here. What we're trying to say is this distance right here is equal to this distance right here. Let's call this y, right? So we're trying to say it's equidistant from the line x equal 3, right? So in that case, AP equal PY. And then once you do that, you set up your equation. Now, if it's equidistant from the line x equals 3, what do we know about the line x equal to 3? Now, what we do know about the line x equals 3 is it's a vertical line, suggesting what? At this point, right here, the x value is 3. The y values are all the same, right? That's all. So in that case now, let's go ahead and set it up. So AP is equal to the distance AP is what? The square root of the distance AP is the square root of, this is what? X2 minus X1, and A, remember, is a point 1, 2. So in that case, it's X minus 1 square plus Y minus 2 square. That's the distance AP. Now, in this case, right, we need now the point P, right? We need a distance away from the line x equals 3. So we need to work out now Py equation. Now the length of the line Py, it's very interesting because first thing, this point y can be anywhere on this line, but we know the x value is 3. And then we know this is just y, right? That is just y. That is just y, right? This is just y. Alright, so in that case now we're saying Py is equal to the square root of, now the length of the line is x minus 3 square plus the y value right here, right? So y minus y, we can just put what? Naught, right? Y minus y, we can just put naught. So that is y minus y square. So in that case, we're telling them that the square root of x minus 1 square plus y minus 2 square is equal to the square root of x minus 3 square. Then in that case, we square both sides of the square root gone. So this is x minus 1 square plus y minus 2 square is equal to x minus 3 square. Now you can leave it right there because they didn't say to simplify it. But let's say you wanted to simplify its first term square, twice the product of the two. I'm just simplifying for those who like to simplify. So minus 2x plus second term square plus y square minus 4y plus 4 equal x square minus 6x plus 9. In that case, we notice that the x squares cancel each other. Right, and so what we are left with is the minus 2x. Bring the minus 6x over here, it becomes positive 6x. So we have y squared. Bring the minus 6x to the left, it becomes positive 6x, and 6x minus 2x is 4x. So y squared plus 4x minus 4y. And we can add 1 and 4 is 5. Bring the 9 to the other side. So bring the 9 to the other side. We have 5 minus 9 is minus 4 equal to 0. And that is that. Right? That is that. That's the equation of our locus. Nice. Okay, question number 5. We're in module 3. Limits. Right here, so there's many ways you can do limits. You can use L'Hopital's rule. If you notice you're plugging in 2 and you're getting 0 over 0, you can use L'Hopital's rule. I'm going to use all the different methods, guys, just for those who like to use all the different methods. Say 2 squared plus 3 times 2 minus 10 over 4 plus 2 is 6. 6 minus 6 is 0. You notice you get undefined. So you cannot put in the 2, so we can use L'Hopital rule. So this is method 1. Method 1, it becomes the limit as x approach 2 of. Differentiate the numerator, you get 2x plus 3 over differentiate the denominator, you get 2x plus 1. Now we can input 2, you get 2 times 2 plus 3 over 2 times 3 plus 1. You get 4 plus 3 is 7 over 2 times 3 is 6 plus 1 is 7. 7 over. Why have 3 here? Sorry, 2. That is crazy. Guys, I'm doing some crazy stuff tonight. Alright, so this right here is 2. And 2 times 2 is 4. 4 plus 1 is 5. So your answer is 1.4. Now method 2, for those who are used to it this way, limit as x approach 2 up. Factorize the numerator. X squared, so it's x and x. Signs are different, bigger number positive 5 and 2, bigger number positive plus and minus. Denominator x minus 2 times x plus 3. Then in that case now we notice that the x minus 2's cancel. And then you input now 2 in the equation to get 2 plus 5 over 2 plus 3, which is 7 over 5, which is 1.4. So that's method 2. Then method 3, which is not really a appropriate method. Remember, we're approaching 2, so you can try x equal 1.99 and x equal 2.01. You'd input 1.99 in that function. So if I bring out the calculator, and instead you input x as 1.99, it's going to give you roughly the same answer. So this one is more, this is what we call the investigative technique, investigation method. So just instead of putting in x as 2, you put in 1.99 because the arrow mean you're approaching 2 but not yet 2. So see there, you get 1.40. So when you try it, you would end up get that the limit as x approach 2 of, let's just call it f of x, you'd still get your 1.4. If you do it this way and this way, you get your same answer being 1.4. So, you know, that's just an alternate way to do it. Really nice. Part B. Part B says a ladder which is 10 meters long. Now, guys, once I see worded problem, you know what I'm going to say. Picture it. I cannot just do the math. Maybe you're good at it, but I have to picture it. So a ladder is 10 meters long and it's leaning against a wall. So I draw my wall, right? This is my wall. And they say a ladder is leaning against the wall. So I don't know how the ladder is leaning, so I'll just put something like this. This is my ladder. And they tell us that the bottom of the ladder is sliding away from the base of the wall at a rate at 4 meters per second. So this is it, it's sliding away. So after this is step 1, then next thing it gonna do is, this is step 2, it slide away some more. So it reach further out, then it gonna keep on sliding away right? And it's sliding away. At the bottom, it's sliding away at a rate of 4 meters per second, right? So it's sliding away at a rate of 4 meters per second. Then it says determine the rate at which the top of the ladder is moving down. So we need a rate at which the top of the ladder is moving down. First thing is the ladder is 10 meters, right? The ladder is 10 meters. And they said determine the rate at which the top of the ladder is moving down when the bottom of the ladder is 6 meters away from the base. When the bottom, let me read this again, when the bottom of the ladder is 6 meters away from the base of the wall. Okay, so they gave us this length is 6 meters. All right, cool. So in that case, right, we know that it's 6 meters away. The ladder right here, the top of the ladder, and we know that the bottom of the ladder right here is 6 meters away from the base of the wall, right? So in that case, over this side now, whatever you want to call this side, I'm going to call this side, just going to call it x, right? I'll just call it x for now. So we know, look at this, follow what I'm saying now. So what they did give you was that the base of the ladder, it is, sorry, the rate at which the top of the ladder is moving down the wall is what we want to find, but they gave us what? They gave us the bottom of the ladder is sliding away from the base. So the bottom of the ladder is sliding away from the base. I'm just calling it dB. Bottom of the ladder is sliding away from the base, being 4 meters per second. That's what they're telling us. And we need to determine the rate at which the ladder is moving down. So I'm just going to call it capital D, meaning moving down now, right? So B right here, let me use a different letter. Sliding away or sliding to the side. So I'm going to use the letter S because it's sliding to the side. So sliding to the side is 4 meters per second. 4 meters per second, sliding down is what we need to find. Now this we know we can rewrite it as d by d of something times something dt. That's what we need. But based on what we have ds dt. Ah, so we do have ds. Alright, so since I'm using that right there, I noticed, wait a second, can't I get an expression for the ladder's movement coming down? Yes, we can. Look how we can get that expression, right? So in that case, look what we're saying, right? Okay, so we know the entire length of the ladder and we know the base of the ladder, right? So clearly from Pythagoras theorem, 10 squared is equal to 6 squared plus 8 squared. So we know that the ladder should be, right, 8 meters up, but we're not writing 8, we're just going to put s squared. Follow what we're doing. This is s squared. So in that case, we're saying, since we have this expression, right? We have this expression so far, right? Follow what we're doing. Follow, right? And let's say we didn't know the base. We didn't know the base. Let's say the base was x. Follow. Let's call the base x now. So this 6 squared, there's a reason why I'm calling it x. Remember, as it slides away, all right? Remember, as it slides away, right, x going to change. So when it's 6 meters and it slides to the left some more, x value will also change, don't? So initially it was 6, but when it slide away some more, it gonna maybe end up reach 8. Then when it slide away some more, it gonna reach 9 until it slide away fully, don't it? So this side we're calling the variable x, right? Sliding away that way. So in that case, this is what we have. Cool. So if we go ahead now and make x squared, if we go ahead and make x the subject when it slide away, x is what? The square root of 10 minus s squared. Ah, yeah man, that's x. X is 10 minus x squared. So in that case now, right, this is now just the square root of 10 minus s squared. Well, we need to differentiate it first because this is the expression for its movement going down. So in this case now, right, we need to differentiate this, and then we're going to multiply that result by ds dt, which is 4. So let's go ahead and do that. It's just connected rates of change, guys. It's connected rates of change. So differentiate it now, carry down the power, subtract 1 from the power, minus half, multiplied by the derivative inside the bracket, minus 2s times 4. In that case now, it becomes the minus 2 cancel the half. So in that case, it is now minus 4 over, this is now the square root of 10 minus s squared, and it's minus 4s. But then they told us that this was what? In that case, we're going to plug in when it is 6. So just plug in s as 6. So plugging in s as 6 now, this is minus 4 times 6 over, want to make sure we differentiate it correctly. Carry down the power, half, subtract 1 from the power, multiply by the derivative inside of the bracket here. Good. So in that case now, alright, in that case now we get square root of 10 minus 6 squared. Punch this in the calculator. 4 times 6 over square root of 10 minus 6 squared. And what we're getting is 10 squared minus 6 squared. I was just about to say what went off. That's equal to 3. So this is equal to 3. 10 squared minus s squared. I transposed. Yeah. So in that case, now that is what we're getting. 3. So in that case, right, as it slides away 4 meter to the left, it is sliding away 3 meter downwards. That's all we're saying. So 3 meter per second is the answer. So all we're saying, guys, is I want you to follow in a picture what we're saying. What we're saying is at the start, look, I want you to see it. So we have our ladder against the wall. This is the ladder, right? The ladder lean up against the wall. So originally it lean up properly. So when it lean up properly, right, this is our ladder. I know I'm not drawing it well. This is the ladder. Originally what's happening is as the ladder stays up and it move over 4 meter now, when it move over 4 meter, it slides down to. When it slide down, so it slide over 4 meter at first, then it gonna slide down 3 meter. In that case now, remember length of the ladder is 10. When it slide over another 4 meter, so now this is the wall. When it slide over another 4 meter, so now it end up slide over to what? 8 meter. So this now would be 8 meter. And then it do what? Slide down another 3 meter. And it slide down another 3 meter. Right? So it slide down another 3 meters. So in total it slide down 6 meters from the top. Right? That's all it is saying, guys. That is all. So when it slide down another 4 meter, it gonna slide down 3 more meter. That's all we're saying. So 3 is your answer. Easy. 3 meter per second it's sliding down. We ignore the negative. The negative just means it's going down. The negative mean what? It's going down. The negative means it's going down. Part C, this says a function f of x is this. Find the stationary points. Remember, at a stationary point, f prime of x or dy by dx equals 0. So that becomes 12x squared minus 6x, that's equal to 0. We can divide through by 6. Dividing through by 6, we're going to get 2x squared minus x equals 0. Factor out x, so we have 2x minus 1 equals 0. So x equals 0 or x equal to a half. So get the two x values at the stationary point, but now we need the y values. To get the y values, you plug it into the original equation. So this is now 4 times that in the original equation. Well, when you put in the 0, that's clearly 1. And then when you put in the half, that is the troublesome part, putting in half. 4 times, calculator, come on man. 4 times a half cube minus 3 times a half square plus 1. Punch that in the calculator, you get 3/4. Now that you get 3/4, your stationary points are, let's write down the stationary points. So the stationary points are, it is 0, 1, and a half, 3/4. That's it. 6 marks, nice. Why is this 6 marks? I cannot understand. Wow! I cannot understand why that is 6, but we take it. Next part, it says determine the nature of each stationary point. Now, for a cubic function like this, right, we know a cubic function will look like this. So now the lower x value is the maximum stationary point and the bigger x value is the minimum stationary point. But because by sketching it doesn't work as a proof, you're going to have to do what we call the second derivative test. So f prime prime of x is equal to, differentiate it again, 12x squared minus 6x. When you differentiate it, it becomes 24x minus 6. Now at the point 0, 1, f prime prime of 0 is equal to negative 6, which is less than 0. So we conclude, therefore, 0, 1 is a maximum stationary point. Then now we need to go further and plug in now at the point where x is a half. So at a half, 3/4, we're going to tell them that f prime prime of a half is equal to 24 times a half minus 6, that is greater than 0. And so therefore a half, 3/4 is a minimum stationary point. And that's it. Nice. Now it says determine the absolute maximum and absolute minimum of the function. This is where the sketch ideally comes in play. So remember, this is the sketch of the graph, right? The sketch of the graph gave us the maximum point was 0, 1, and the minimum point was half, 3/4. But no, they restricted the domain, right? They restricted the domain and they went further and told us that we're looking at a domain where x is negative 1, right? And here it is, they told us the domain x is between 1 and negative 1. So we need to first find out. So first let us go ahead and find out f of negative 1. So first thing, f of negative 1 would be equal to 4 times negative 1 cube minus 3 times negative 1 square. Then we have plus 1. We need to find out where that point is. So change this in a calculator to negative 1. Punch that in. Bam, we get negative 6. So negative 6, so negative 1 is somewhere maybe right here, right? This point is negative 1, negative 6. Now let's plug in f of 1 now. F of 1 is 4 times 1 cube minus 3 times 1 square plus 1, which is, plug in now as 1. And we'll get 2. So when the x value is 1, the y value is 2. So in that case, we can tell them the absolute maximum and the absolute minimum during this region. So in that case, the absolute max is equal to positive 2, and the absolute min is equal to negative 6. That's it. Easy. Nice, because this is where we're at for x and y values. I know I didn't put on the x-axis, so many persons might say, sir, where's the x-axis and the y-axis? That's fine. Right, this is fine. So 0, 1 is the y-axis intercept. I know I didn't put in no I know I did not put in any axis to show 0, 0 the origin, but just bear with me, right? Just bear with me, please. Just bear with me, right? Just bear with me. That's it. Okay, all right. So question number 6. Using u substitution, do this integration. So if u is equal to x squared plus 1, then du dx is equal to 2x. But I notice, right? I notice they have a 4x right here, right? They have a 4x dx. So what I can do is multiply cross by dx to get du is 2x dx. Let's call this integral I. So I is equal to the integral of 4x in bracket x squared plus 1 to the 5th dx. I can rewrite it as the integral of x squared plus 1 raised to the 5th power times this right here is now 4x dx. Now I realize 2 du would be 4x dx. So in that case, this becomes the integral of x squared plus 1, remember, is u, so it becomes u to the 5th, and 4x dx is 2 du. So in that case, we're integrating 2u to the 5th du. So add 1 to the power, 2u to the 6th. Then we divide by the power of 6 plus our constant c. So finally, this integral works out to be 1 over 3 u to the 6 plus c, which is 1 over 3. And remember, what was u? X squared plus 1 plus your constant of integration. That's it. How many marks for that? Whoa, 5 marks for doing absolutely nothing. Nice. Next part, can bet you they're going to ask for the area. So first thing is they give you the curve and ask you for the area. First thing to find the area, remember to find area, it's area above minus area below. So area shaded is equal to area above minus area below. So first thing you need to find out which curve is above. The curve that is above is, well, first thing is they didn't give us the points. Well, they did give us 1 point of intersection. They tell us the origin is 0, but we don't know which point of intersection this is. So first, finding point of intersection. So let's go ahead and find our points of intersection. That's all the space they gave us? Whoa, that's so harsh. So we have to find the points of intersection. So first, for intersection, we need to go ahead and solve 3x minus x squared equal to x plus x squared. In that case, we bring x squares to one side. This is now 2x squared. Bring the x over here. This is 2x. In that case, we divide through by 2. X equal x squared. Bring it over. So x minus x squared equals 0. Factor out x. This is x minus 1 equals 0. So x is just 0 or x is 1. Beautiful. So the point of intersection is 0 and 1 for the x values. That's all we need. Because now we know that it's going to be the area shaded is equal to area above minus area below. So that's equal to area above. So it's the integral from point of intersection 0 to 1. The curve above is x in bracket. Want to make sure it's correct. This is the curve above. Let me show you the curve above. This one is the one above. So the curve above is x in bracket 3 minus x dx minus the integral from 0 to 1 of the curve below, and the curve below is this one. The equation of the curve below is x plus x squared dx. And so integrating this, and sorry about that, you heard the phone ring, so I went and picked up the phone. So we're back now and finished doing this. So integrating this now, it's the integral from 0 to 1 of 3x minus x squared dx minus the integral from 0 to 1, minus the integral from 0 to 1 of x plus x squared dx. We go ahead now and we integrate this. Let's go ahead and integrate this. And integrate 3x, we get 3x squared over 2 minus x cubed over 3. I'm going from 0 to 1 minus, we integrate x, we get x, add 1 to the power, divide by the new power, plus x cubed over 3 going from 0 to 1. You just need to plug in 1, right? So plug in 1, you get 3 over 2 minus 1 over 3. Plugging in 0 gonna be 0, so don't need to do anything. Minus over here, when we plug in the 1, we get 1 over 2 plus, plug in the 1, 1 over 3. Punch all of that in the calculator for me. 3 over 2 minus 1 over 3, close the bracket, minus 1 over 2 plus 1 over 3, close the bracket. And in that case, we get 1 over 3. So in that case, we get 1 over 3. That's the answer. So the area shaded, calculate the area of the shaded region, it's 1 over 3. Now guys, I would like if you put your answer as 1 over 3 units square. That's the area. Please write your unit square. 6 marks, write it. Next part, it says calculate the volume of solid revolved by rotating the line y equals 6x and the parabola y equals 6x squared. First thing is, I love the sketch. The line y equals 6x is just a straight line like this. So when x is 3, the y value is 6 times 3, which is like 18. This is the line y equals 6x. Then the curve y equals 6x squared, right? Now the curve y equals 6x squared would be, first thing, when x is 3, this would be 6 times 3 squared is 9, 9, 6, 54. So the curve looks something like this. I know it's not properly drawn, but bear with me, right? So at that point, when x is 3, the y value would be 54. This would be the curve y equal to 6x squared. Well, first thing we need are what? The 2 points of intersection, right? So 6x equal to 6x squared. I know I draw my curve wrong, let me fix it. The curve it's increasing exponentially. So you're gonna go something like this. That look a little better. So solving it, we'll notice that we divide through 6, we get x equal x squared. And the two answers for this is x equals 0 or x equal 1. So we get our intersection points, 1 and 0. I know my sketch is not good. So the volume of revolution is when we rotate this shaded portion, right? We spin it around. So in that case, volume of revolution is equal to the volume of the curve minus the volume of the line. Alright, or is the line above? I think the line, which one is above come first? So the one that's above is, between the region 0 and 1 is the line. So it's the volume of the line minus the volume of the curve in this case. So in that case now, the volume of the line is pi times the integral from 0 to 1. And remember the formula for volume? Remember, volume is equal to pi times the integral of y squared dx. So in that case, it is integral from 0 to 1 of 6x squared dx minus pi times the integral from 0 to 1 of 6x squared dx. We can write this as one integral, don't? This is factor out pi times the integral from 0 to 1 of 6x squared is just 36x squared minus, from this side it would be 6 squared is 36, so that's minus 36x to the 4 dx. I don't know why the 0 keep disappearing. Stop doing that. So the 0 keep disappearing. I don't know why. So in that case, when we integrate, we get pi times the integral of add 1 to the power, divide by the power, minus add 1 to the power, divide by the power, and we're going from 0 to 1. So that's equal to pi times, plug in the 1, we get 36 in bracket 1 cubed over 3 minus 36 in bracket 1 to the 5 over 5. That's equal to, punch that in our calculator. So fraction button, 36 over 3 minus 36 over 5, and we get 24 over 5, and then we'll multiply it by pi. So that's 24 pi over 5. But remember, volume is what? Units cube. Volume is units cube. Wow! That's our answer. Nice. Easy. Now that we get that, this is the last part of the paper. Guys, look at this. We're doing the test, and you see I'm recording for less than 2 hours and 30 minutes. There's no way the pure maths test should done and you don't finish. You have enough time to do it and check over. I'm telling you, work slowly, don't skip out any steps, and you'll be fine. Look at that. We have a lot of time left. So now we need to solve the differential equation, then we're done. So cross multiply to get y squared dy equal x plus 4x squared dx. Then we do what next? We integrate both sides. So integrate both sides for me, please. When you integrate y squared, you get y cubed over 3 equal to integrate this side, you get x squared over 2 plus 4x cubed over 3, add 1 to the power, divide by the power, then plus c. Now you need to find c, but they gave you when y is 6, x is 0. So when y equals 6, x is 0. So that means 6 cubed over 3 is equal to 0 plus 0 plus c. And 6 cubed is 216. See there for those who didn't believe? And then you divide it by 3, that is 72. So a constant is 72. In that case, now we can write down the differential equation. So in that case, y cubed over 3 is just equal to x squared over 2 plus 4x cubed over 3 plus 72. And that's the answer. They didn't say to make y the subject. You could, since it's 8 marks, you could. And I don't even see why this is 8 marks, but they decided to give us 8. So I guess just to get the full 8, multiply through by 3. So it becomes y cubed is equal to, multiplying through by 3, we have y cubed equal 3x squared over 2 plus 4x cubed plus 260. Then cube root both sides, so y is equal to the cube root of all of this. The only reason why I'm doing this is because I see 8 marks and I cannot comprehend why this is worth 8. So I want to do everything to ensure that we get full 8. Alright, and that is it. So I really hope this video is beneficial for all those who are practicing from the last year paper. And of course, I will do the Add Math paper 2, the Unit 2 paper 2, and also the Unit 1 paper 1. Everything will be coming soon.